Yeah.
Okay.
Yeah.
Okay. Thank you. Yeah. Sorry for waiting. Okay. So hello everybody. I am Borong from Tsinghua, from School of Architecture, Tsinghua University. It's my pleasure to join the Sino-UK Journal Symposium on the post-novel COVID-19 errors. So today my topic is online monitoring and intelligent analysis for the highest indoor environment. And firstly is the background. Yeah, as you know, HICE becomes a top trigger for the development of global building industry, especially in the post-COVID-19 pandemic era. So IEQ play an important role on the human health. There are some challenges. Firstly, is the IEQ has complex spatial and temporal characteristics due to many, as you know, influencing factors. It's very hard to understand in the mechanism of the IEQ environment. So maybe firstly we need to get the solution is the sensing. The question is how to measure accurately and comprehensively within an efficient tools. The secondly is understanding the mechanism. That means how to recognize the key features from the massive high dimensional data. Here I give you some pictures. You can find the difficulties. At the other hand, there are some new opportunities brought by the big data technologies. Firstly is the sensor technology. The secondary is the 5G technology. The third one is the big data technology. So that means if we can get data enough, we can analyze the world based on the massive environmental data, as well as something as just as the energy consumption data. So our solution is the SUC, or say the SUCF. That means with the measures, sensing, and then understanding, and then we can control the environment by the rulers from the understanding, and finally give feedback to the real environment with the control rulers or strategies. So with the SUCF approach, we can understanding the environment quality. We can build a health environment by these systems. So the first challenge is how to solve the sensor issues. It's very important for the data collection. So our team developed an equipment named iBeam, which is an intelligent built environment monitor. We integrated the temperature, relative humidity, as well as CO2, PM 2.5, and illuminance, and so on. Yeah, many environmental parameters into a very small sensors, and then we can transmission the data to the cloud through the Wi-Fi or 3G. This table shows you the details comparisons from our sensors and the others. That means we can get the advanced parameters with this comparison. And also, we carry out a series of sensor calibration works. I show you below. Firstly, we need to carry out some sensor comparison, and then we carry out a thermal interferences simulation between the modules with the CFD, and then we work hard to optimize the hardware, and then we carry out the calibration under the national standards, and finally the machine will be certified by the third party, and then we can use this sensors to the real environment monitoring. With these systems, we build a big data platform and an interactive interface. We built a web plus mobile platform to carry out the data query, download, evaluation, and feedback. With this system, we can get right here and right now evaluation for the real environment, indoor environment quality by the subjective votes and by the objective parameters at the same time. So that means you can use WeChat to scan the QR code, and then we can carry out your subjective response. And then we can compare these subjective votes with the real parameter environment indexes. And then this evaluation will be very scientific. So with this approach, we build a large-scale measurement and a database. This system was installed in 209 buildings in 31 cities in China and abroad countries. The total floor areas is about 10.3 million square meters. With this system, we also carry out long-term high frequency, just as 5 minutes, in high density in large scale database for understanding the mechanism of these the IEQ issues. As you know, you can see the data size equal to 1.1 T. And also, due to the COVID-19 happened last year, these systems was quickly installed in the hospitals in Wuhan. There are 8 hospitals in Wuhan installed 224 ITIN sensors, and also in Beijing. These systems can support the early warning of the highest risks during the COVID pandemic. And lately, we also introduced this system for the subway stations security track. Because use the sensor, we can develop a safety ventilation strategy for the platform and for the independent carriage of the subway. Secondly, is the understanding of the IEQ mechanisms. Firstly, we carry out a nation-level study. These figures reveals the overall IEQ performance of green office buildings in China based big database I mentioned before. We found the thermal performance is worse than the IEQ and lighting. And the typical problems are insufficient cooling in summer and overheating in the winter. Yeah, these figures show you the details. If you want to get the details, you can check these papers from Building and Environment 2019. And secondly, we build a details understanding. We establish the monitor IEQ field. It's a 3D field based on the multi sensors instead of the traditional analysis with the single point. This approach has a good advantage. That means we can use more spatial characteristics to understanding the problems happening in the environment field. These two dynamic figures show you the different PM 2.4 parameters changed all by all, as well as the CO2 sensors. So for everyone, it's very easy for you to find the problems inside this office platform. Another approach is we installed these systems in the Beijing International New Airport Terminal buildings. And also we can find that the thermal problems are very easy to check. It's all coded in the waiting corridor, just in the D, yeah. From 4 p.m. to 8 p.m. Is the most uncomfortable time. The concentration of the 2.5 in the corridor C, is very high. That means we need to clean the air right now. Similar approach also installed in the hospitals during the COVID-19 pandemic. This is what we installed in the Wuhan hospitals. We also found the PM 2.5 distribution. That means it's very easy to bring the COVID-19 virus with the PM 2.5 or PM 2.10. So that means we need to very quickly use the natural ventilation plus the air cleaner to solve these problems. And also, we can carry out some data mining issues. So we can use the daily pattern like this, carry out some recognition work from the massive 10 series data. And here we develop a new 10 series clustering method based on the combination of the professional knowledge in the feature engineering. That means we integrated the numerical features plus the trend feature together to analyze the data. Here I show you some examples. We carry out the temperature daily patterns in an office building. And finally, we found there is a 5-day curves obtained, and we can get an unreasonable operation mode, just as class 1, the right one. And the typical pattern of each zone and each day will be recognized. In the zone with the poor thermal performance will be found and identified easily. Another work is we also use this data mining approach to predict for the future trends by the historic data. We compare the different machine learning algorithms, and finally we find that the Royden-Foster platform will be better than the ANN and RISTM approach. So use this, we can get a better performance with the Royden-Foster platforms. Okay, the third one is the control. We use the indoor occupant position technology plus the IEQ monitoring, and finally we can carry out a demand-based control for the IEQ. Firstly, we use the camera plus the Wi-Fi technology. We can get a very accurate position of the occupant inside the office buildings. And then we can get the distribution 10 by 10. With this occupant position plus the IEQ analysis, we can easily carry out the IEQ performance optimization in the real engineering. Okay, and third one is we plus this IEQ demand with the real-time location in the real-time IEQ plus the real-time vote, what I introduced before, just by the WeChat. And then we can carry out a smart control because we can use the cloud-side IEQ simulation engine to obtain the control strategy. And then we finally will be realize this strategy in the real work. This is some applications in the Shanghai Hongqiao Airport Terminal 1. The finding is we saved 60% energy for the air HVAC systems. In the IEQ satisfaction rate, more than 85%. Recently, we also carry out some new tests. The question is current sensing technology enough for us to understanding the IEQ? In fact, no. Because we need to consider the following issues: the spatial continuity problem, in how to collect IEQ data in the unaccessible areas. So we propose use a mobile sensing instead of the static sensing. We introduced the mobile robot as a carrier for IAQ sensors. So this is our attempts. So what I show you is we integrated I-beam sensor into a mobile robot for mobile sensing. So also from theory side, we develop a static plus mobile sensing measure for generating the whole spatial temporal understanding of the IEQ. This is the some findings. That's the schematic diagram. And this technology has a very amazing potential in the future. We can integrate the overall measure and Lagrange measure together, carry out some analysis in the future. The scenario including the transition space, just like this. And also for large space. And for the third one is the high risk space. Anyway, in the future, if we integrated the mobile sensing for the IQ, that means we can get a more high environment in the future. So, due to the time limited, this is my introduction. Sensing, understanding, and control and feedback. In the future, we can get a better, healthy environment. So that's all. Thank you very much.
Thank you, Professor, for giving us this keynote speech. Let's give Professor a round of applause.
Thank you.
All right, so we're now moving on to the question and answer portion. So we can ask Professor Borong Lin for some questions. So you can actually unmute yourself, or if you are shy, you can just chat it out. So anyone who would like to ask a question? Oh, everybody's shy.
Yeah.
Hello, I have a question. Hello.
Okay.
Go ahead.
What were the challenges in terms of gathering data in your project?
Sorry.
Especially on getting gathering data in hospitals and airports. Were there challenges?
Okay. Yeah. The big challenge for us to get the data in the hospital is because for some serious risk space, especially for the COVID-19 situation, we can now really enter into this space by ourselves. We only to ask the